welcome to SEC211-S. So we're going to obviously talk about security stuff. My name's David Mills, and this is Nick, aka Nicholas Jackson. And our goal for this session, as it is for all the sessions that we deliver, is for you to take away at least one actionable thing from this session that you can take back to your organizations and help improve your security. So we'll try to make that happen. And so obviously today we're going to talk about agentic systems, how those can be problematic, how they can do wonderful things, but also be problematic because you have so many non-human identities that are tied in with these agentic systems and often not well managed, either not tied to a real human, they don't have the right policies assigned, and where that can get you into trouble. So with that, I am going to let Nick walk you through what the agenda items are and what we're going to talk about today.
So we're going to look through, I think, predominantly some of the risks and the threats that can affect agentic systems, the development life cycle, because we're going to kind of look at that as a potential threat in addition to the sort of the runtime of your systems. How you can do things like protect systems. Predominantly what we're going to concentrate on are looking at things like secrets. All agentic systems, like microservices, like anything else you're building, is going to have a requirement for secrets, whether they are dynamic, static, PKI, all of those kinds of things. And we're going to look at this from I think, like a cautionary tale. A little bit of a scenario for you, which looks at, I think, quite an interesting way, which makes an agentic system a little bit more vulnerable than an ordinary system. And of course, how you can address many of these threats, and of course, one of the most important things which kind of comes out of a lot of this, which is looking at agentic identity and how to manage that.
All right, with that, let's get started. We got a lot to cover today, so we might move a little quickly, but definitely provide a lot of good information for you to take away. So most of us have seen the big news headlines about breaches that are happening. A lot of them are happening for reasons of just not enforcing basic security practices, which we're going to talk about. But AI is involved in these. So McDonald's had exposure of 64 million job applications. There was an AI agent that was accessed the records using a basic password attack. I think it was something like 1234556 for their McHire platform. Samsung implemented a crackdown after somebody accidentally put source code in ChatGPT. And so this was some IP that got exposed via ChatGPT. And ServiceAid was subject to HIPAA violations and fines after a data breach was discovered. And this was related to an Elasticsearch database that was exposed for more than 6 weeks. 483,000 patient records were exposed. And these could have been avoided using basic security practices being put into place. So if you look at the top risks, just a few years ago, it was injection. So think SQL injection. And some of you might have remembered the memes with little Bobby tables or drop tables that was being used. So basically just some really bad formatting to do bad things in databases. And so over time, companies, organizations learned to be more careful about parameters and how they were formatting things to avoid this problem. But here we are again, and currently now we've got prompt injections as the number one problem. So it kind of feels like we need to learn those lessons all over again. So let's start by looking at what the attack surface is, what the architecture looks like for an agentic system. And then I'm going to walk you through some of the most common categories of those threats. We're not going to dive deeply into all of them because that could be a separate session, but to give you some context for what's going on here. So here we have a system that has a user. They're obviously wanting to do something with AI, and they are accessing and asking agents to do things for them. Those agents are connecting to tools. Those tools then are accessing services to be able to do what they need to do. And so if you go from left to right, there's a lot of moving parts. And we start thinking about the fact that these new agents are so autonomous, and they start making decisions on their own. They're not just making decisions based on predetermined answers, which is kind of where we started with some of the AI stuff that we worked with. They have adaptive learning. They're continuously learning and adjusting their behavior, and there's this expanded attack surface. So you can see from left to right, there's a lot of different stages and a lot of different vulnerability points in this architecture. So let's go through some of the major categories. One is obviously identity and authorization threats. So something that you may have heard called confused deputy. This is where you have a service with high privileges, more privileges than they should have, because those policies or privileges were not enforced correctly. So if the user that's using that agent has only read permissions, that agent should not have write permissions. So some of those things are really basic. If we look at credential and secret management, secret exposure and theft is a huge one. And there still exists a major issue with long-lived credentials. So if you're not rotating the credentials, they're hard-coded, you've got a lot of sprawl, and the more sprawl you have, the more vulnerabilities you have. Tool and integration and exploits. So we look at some of those tools and the fact that they're integrating with services, different things happening. There's something called a tool poisoning attack. That can lead to sensitive data exfiltration, unauthorized actions, and it's really about the APIs not having robust authentication, and it makes them particularly vulnerable. Supply chain attacks. So in working with AI and working with these agents, most organizations are starting to adopt the model context protocol. That makes it easy to integrate whatever your agentic or AI platform is with your databases or whatever you need to integrate with, because you don't have to make these bespoke AI integrations. MCP servers can do that for you. But those MCP servers can also be vulnerable. Their server registries, their patch and update mechanisms introduce a new surface that can be a threat and that can be hijacked and do things like inject malicious code. Multi-agent systems. So in many cases, it's not just one agent that you're leveraging to do what you need to do. There can be a control agent, and there can be other agents that that agent is controlling for things that it needs to do, pulling records or doing other things that need to be done. So if you can inject or tamper with messages between those agents, then you can inject false information, and that propagates across those agents that are communicating and get them to do bad things. Prompt-based attacks. Direct prompt injection is the one that I mentioned now. It's the #1 vulnerability. And that's a situation where you can use carefully crafted commands that can override agent instructions. So a recent example of this, sorry I'm laughing, is when a Chevy dealership's AI chatbot was tricked into offering a $76,000 Chevy Tahoe for just $1. Yes, that happened. I'd love to get that offer for a Porsche Taycan, but that's another conversation. Data security threats, RAG poisoning. So basically you have retrieval augmented generation systems that we're starting to rely on. That's a technique that allows you to get retrieval-based and generation-based input to improve performance and accuracy of these agents and some of these language models. And the two biggest risks associated with the RAG systems are the poisoned databases and then also leakage of sensitive data. In terms of runtime and operational threats, you've got tool misuse, and agents are tricked into calling tools with the wrong credentials or elevated privileges. So once again, it comes back to basics where you've got credential problems and you've got elevated privileges that you can take care of before this ever happens. Detection and guardrail evasion. There are some categories here that are very sophisticated. Sometimes just ensuring simple security principles are not enough. Multimodal attacks is an example here. So if you can exploit different input types to embed malicious instructions and formats that evade detection, then that is a problem as well. So for example, adversarial text can use carefully crafted phrases, and that can mislead the agent to do things it shouldn't do. These can be harder to detect because malicious content may not be distributed across different media types. So in the healthcare sector, multimodal models are often used in critical diagnostics, treatment planning. The systems may use contributions from text-based medical records, imaging like X-rays or MRIs, and then even real-time sensor data. So the multimodal part is they're getting input from all different types of formats and different types of data, so that's very complicated. In terms of compliance and governance gaps, simply having audit trails is really, really important, but that's something that is not always in place when people are using agentic systems. So those audit trails obviously make it possible to trace agent actions back to human authorizers and for you to do forensics when things like this happen and when things go wrong. So as you can see, there's a long list of vulnerabilities in what we kind of put together in 10 logical categories. And so that's a lot that you need to think about, and that's a lot that you have to fend off. Prompt-based exploits account for 35.3% of all the documented AI incidents. There's $100,000 a loss on average with losses that are being caused without writing code. So you have some of these text-based attacks that seem very simple, but very possible and that are being used now. The zero-click vulnerability, one that was known as Echo Leak, enabled data exfiltration from Microsoft 365 Copilot through pure text that was embedded in normal business documents. So the payload requires no code execution, Copilot behaves like it's supposed to, and then it processes this malicious prompt when the user opens a seemingly innocent file or something that's innocuous. So with that whirlwind tour of all of these categories, security challenges don't just emerge in production. So you need to think about this in development and where some of these things can be guarded against and where some of them get introduced. So Nick's going to give you a dive into the whole agent development lifecycle and kind of what happens there and how you think about security.
So as David kind of said, we just looked at the landscape of your agentic applications running in production. You can see there are a number of threats on them. Some of them are fairly aligned to running something that you might see in a microservice system. But the software development lifecycle or the agent development lifecycle is equally important. And there's a number of threats which kind of are, make your application vulnerable. So this chart here comes from a paper that IBM authored and was validated by Anthropic. And it looked at secure enterprise application development. So this is predominantly looking at the application development lifecycle. And anybody who's looked at software development lifecycle will see that it's very similar. So the area that I want to concentrate on is build and test. So let's kind of have a look at this. So when you're looking at the build and the test phase, you sort of have to consider certain things. So the IBM document says that we should be looking at things like hybrid models by design, looking at hybrid cloud by design, looking at interoperability, building things which are tool-centric, importantly, secure by design. And I think this is something that we've kind of learned over a number of years to kind of have that approach of just building secure by design as a first principle of developing any new feature. But also we need to look at the kind of the blast radius and trying to look at our agents and our tools and putting them in a box, kind of really having them heavily restricted so if something does go wrong, then that is constrained. Now, where I kind of want to put a little bit more emphasis on this is looking at vibe coding. How many people here vibe code? Right? And are the rest of you lying or have you not tried it yet? Right? I mean, seriously, it's a very powerful tool. I use it myself. I love using it as a tool because something for me as an application developer, it assists me to get my job done really quickly. But the key thing is when I'm looking at vibe coding, my mind is in a very different place than it is if I'm just writing plain application code, doing pair programming, or writing on my own. I'm looking at things inadvertently, things like speed over security. I'm just kind of working through this. I'm just mashing away, right? And where this kind of causes problems is it introduces new areas of supply chain attack. I can have issues where maybe I'm not validating dependencies as tightly as I would if I was manually kind of authoring the code or going through a sort of a more formal process, because this is a new world, right? So we're kind of breaking the rules here to increase velocity. And the key thing I think around a lot of code that is written when you're kind of using some wonderful tooling like Claude and things is that you have functional correctness, but you don't necessarily have security. And where you kind of, this can kind of fall down is let's think of a little scenario here. So what we're going to look at is a little scenario. So I am a junior developer, and I am going to be using Claude. I am empowered to write a feature for an agent. And the feature is going to be that I'm going to add a new endpoint to my weather tool. Now, as a kind of a good practice, my company has provided me with a bunch of best practices that the agent is going to use. All of the kind of the good development practices we've encoded into a document that the agent can understand and can use. So we start off and we're like, hey, okay, I need to add a new endpoint to the weather tool that can go and fetch the weather from Open Weather API. So we go through that, we type the prompt, and we hit the button to make it do its thing. At this point, I'm kind of sitting back watching a bit of Netflix, watching YouTube. You know you do it. But my attention is switched off, right? It's not in exactly the same place as if I was writing this code myself. And it's not by any other kind of reason than it's just a different way of working. So Claude is going away there. It's using the best practices document. It's generating the code for me. It's kind of spinning through that. It's kind of written that endpoint to be able to fetch the data from the API. And then we want to go through and sort of test it. So yeah, it's just validating against the corporate best practices there. And then in a second, I'm going to go through and I'm going to test this, right? So I'm like, well, how do I test this? I'm getting a little bit lazy, so I'm just like, hey, Claude, just go test this for me. So I stick my Open Weather API key in my environment file on my local computer. I hit the button, I go back to Claude, and I'm like, make sure this works. This is a fairly sort of typical flow that I would take on a day-to-day basis. And Claude comes back, and it's like, yeah, everything works. And I'm like, great, right? This is job done. I've just achieved in a matter of minutes what potentially could have taken me a number of hours. So I'm just like, ship it, right? Like, again, the key thing is, what I want to kind of stress is that my mind is in a different place. Like, all of those skills and those things that I have learned over the years as an application developer, I'm kind of just forgetting about right now because this is great. This is all just working. That's functionally correct does not equal secure.
Code nirvana.
Right. So I'm going to go a step further. I'm even getting Claude to generate me the Kubernetes deployment manifest. I'm getting it to generate me the Docker files. And it does it very, very, very well. But there are some problems. And we'll kind of see this in just 1 second. The problem comes that, again, it's about that attention. Where is my attention? And my attention now is just ship it. So I've got the secure pipeline, everything is ready, I git commit it, I push it to GitHub, and everything is perfect, right? We're done. We can now put Slack on Do Not Disturb for a few hours, slope off, and do some other stuff. Well, until.
Ready for it?
Uh-huh.
Okay. Okay, we're done with that, right? All right. We're not saying don't do vibe coding, right?
No, we're saying absolutely do vibe coding. Yeah.
But you need to put guardrails in place.
Right.
Okay. That includes the ability to monitor unsecure secrets and other things while you're doing this. Okay. So, HCP Vault Radar is a product that will go out and scan data sources and monitor data sources when unsecure code gets introduced. So I'm just going to walk you through this a little bit. So this is an example of a tool you could use to solve some of these problems that we were walking through in the category. It detects over 300 patterns looking for secrets and unsecure data. It looks for entropy and complexity. that helps you find some of those more complex secrets and keys that are out there. It does activeness and version checks to see whether the secrets that you find are currently active or are they in Git history, and it will assign severity and risk rankings to them. So it helps you figure out how bad your blast radius is from doing some of the things that you do and letting unsecure secrets get out in the wild. It currently supports Git servers, collab platforms like Confluence and Slack, and will even scan in your IDE, currently supporting VS Code to do that. There's also integration with tools that can help you alert or automatically generate tickets and do other things. So when you start thinking about the front end of all of this, think about how do you, number one, discover all the secrets that are kind of out in the wild that might be long-lived, that are putting you at risk, but also then how can you monitor these data sources to make sure if something is about to be introduced that you can catch it before that happens. I also wanted to talk about the fact that we have integrated Vault Radar with AWS Secrets Manager. So as much as you want to find these secrets that are out in the wild and get them under control and being managed, sometimes people mismanage secrets that are currently being stored. So we are able to index AWS Secrets Manager securely with Vault Radar. If you have a secret that gets out in the wild, you will know whether it's also being stored in AWS Secrets Manager, who owns it, and then go back to that person to be able to get them to remediate it and talk about how to better handle secrets and not let them get out of your secret manager. So it integrates with Vault, HashiCorp Vault, our product, AWS Secrets Manager, and you can expect to see more secrets managers being added that will allow you to do that correlation. You are also able to get remediation steps that are customizable. So if somebody finds a certain type of secret in a certain type of location, they get instructions to consistently handle that the right way, whether that is importing the secret into Vault, which you can currently do, and then basically you could use something like Copilot to be able to create the code wherever it was hard-coded to point to Vault to make sure that it gets the secret there and it's no longer in the code. So you need a way to effectively be able to remediate this stuff when you find it. And Radar also will scan as far left as your IDE platform. So you can get alerts if there's a secret that's in code. As soon as that gets saved, it'll pop up, gives you remediation steps, the ability to copy that into Vault. But we're also scanning in the CI/CD pipeline and then pre-receive and pre-commit phases as well. So with that, let's take a quick look at what Vault Radar looks like to help you do this.
Yeah,
so this is...
I was going to say, nobody spotted my deliberate mistake.
Yeah. No, they didn't. So this is the overview dashboard where you can see all the data repositories that you're monitoring. You can see all kinds of helpful metrics about it. You can see what are the most common types of secrets that are being discovered that are unsecure, who owns them, who are our biggest offenders in this dashboard, and all kinds of other interesting data. But ultimately, I'm not going to be sitting here just staring at the dashboard for this product and saying, I'm watching for a new event to happen or an unsecure secret to be discovered. So I want to use the tools integration. In this case, I've connected it with Slack and I've configured a channel where I get alerts whenever something's introduced. And here I can see I have a high severity incident that was discovered, who the author was for that, what time it was, and a link to go directly to the source file where that was discovered. And I can see that where this is, where the file is. It's in my cat generator repo that I've been monitoring. I also can go back to the event that's in Vault Radar, and I can see similar information and details about what type of secret it is. I also have that link to go see where it showed up in code or in the file. I can see it's my weather app .env file. And I also see that that's something that's being stored in AWS Secrets Manager. So that's good to know. Somebody has mishandled that. I also can click on a link for remediation instructions. So when I found this, I can go in and get the proper steps and make sure that people are following those steps consistently when they need to resolve that issue. So I'm just going to go ahead and mark this as triaged. And because I've configured RBAC for the product, I can hand this off to the proper repo owner or dev owner who needs to go and finish fixing that problem. So with that, let's talk about Agentic AI a little bit more. And you have a cautionary tale for us, I think,
do.
Nick.
So when I kind of was going through before and looking at that little demo of my vibe coding example, My inattention due to being kind of in a different way of working caused me to committing that environment variable to GitHub, a very simple sort of standard mistake that I've made before in the past, and something that I'm actually fairly aware of right now. But again, that shift in sort of concentration. Now, when I was kind of looking at that, maybe there was a deeper problem in that vibe coding example, because did anybody see this when the code was created by Claude? So the requests library, that's not necessarily a standard library. What about this one? Did you spot this when I generated the Kubernetes configuration? So I'm running host network on my pod, right? Well, why would I do that? Well, I didn't. I didn't do that at all. Now, I had best practices in the agent was using, so, well, how did these kind of issues end up in the source code? And the way that it happened was because we're looking at what I think is a sort of an intelligent attack from the malicious. So a malicious person didn't decide to attack my source code directly. They didn't attack the production system. They didn't attack my supply chain indirectly, even though we saw an example of typo squatting there. What they did was they attacked my best practices documentation. So the attacker has found a way to manipulate my best practices documentation that my agentic agent has used. That has caused the code to be produced, which included the typo squatted URL, the package, and also it included the host networking switch on. And what that has done is that typo squat URL will activate a packet sniffer whenever the weather server is running. So whenever a request comes into that tool, a packet sniffer is now running. Now, because that packet sniffer also now has host network capabilities, it's got the ability to basically capture any of the unencrypted traffic inside of my Kubernetes cluster. And unfortunately, I've made other mistakes by not looking at the defense in depth and taking a full zero trust approach, because I trust everything that runs on the server. So that sniffer runs, the credentials are detected, and then the attacker can exfiltrate those back to their own system. So the packet sniffer that's running inside the weather tool picks up the database credentials for Postgres, for the customer database, a completely unrelated tool, and sends them back to be used as is. And the way they did that was very simple. They just used context poisoning. They just injected this very simple statement into the developer documentation that the agent uses. Now, it's just a kind of a backdoor attack, but it opens up a vulnerability that I wouldn't have been affected with had I myself been writing and authoring that code, because I would have, well, A, I wouldn't have used that library, and B, I probably wouldn't have been reading those documentation every single time. I've got it sort of encoded into my mind. And the second step is that they put another manipulation into the best practices. So whenever we are developing a Kubernetes deployment, there is a best practice which says, well, hey, if you've used the requests library, then this requires host networking because of some bug in the library, right? So it's a way that I've circumvented the complete sort of security of the system through something which is probably fairly innocuous. Like, it's something that's not necessarily used very heavily. So let's look at that in action and see how that works. So we're just going to kind of see this. So somebody goes into the UI, and then they're just going to say, right, we're going to use the weather agent. What's the weather like in Las Vegas? TLDR, it probably sucks right now. So you can see that the agent calls the tool. Now, at this point, the tool has activated the packet sniffer. So that is now running in the background. And if we look at the logs, I'm just going to kind of pull you the logs there of the pod which contains the weather tool. You can see there the sniffer's been running. An attacker is obviously not going to be that obvious in the logs, but now we can see the kind of the database that they're going to exfiltrate those credentials out to. So when somebody now goes and uses the customer tool, I'm just going to say, well, hey, get me the customer data, order details for ID8, right? So customer 8. That again calls a tool. The tool makes a connection to the database to retrieve the order details, which has caused a connection from the tool to be opened against the database. And what you can see is that we've now got all of those credentials there. Now, again, there's a number of problems. There's no TLS. There is very, very open credentials being used with the data store. We are not using a particularly strong database connection. We're using MD5 when we should be using SHA-SUM. Very, very simple to sort of to decrypt that using hashcat or something like that. And there's no attribution. We don't know who did it. We don't know when they did it or what went on. So there's like a number of problems that we need to fix, which David is going to start to explain to us.
Yes, there is. So let's talk a little bit about some of the basics. You know how I mentioned at the beginning that there's a lot of sophisticated attacks that are happening based on agentic AI or leveraging that to do bad things. But really, a lot of these things can be stopped if you're using core security best practices. So every AI agent needs to have a unique, auditable identity. There has to be user attribution. So who is the human? What is the human ID that is mapped to this agent so that you can trace that back and so you can make sure that you are not giving that agent any greater permissions than the human identity that is using that agent. Dynamic authorization, no long-lived secrets, nothing that's sitting out there for a long time exposing you, but you need dynamic authorization, some kind of token exchange, not static credentials. And then you also need a framework for consent, so explicit, time-bound, revocable permissions. So these are all kind of core security things that regardless of having agentic AI or NHIs starting to outnumber human identities 50 to 1, 100 to 1, these should just be in place now, but they often aren't. So it's becoming a bigger problem because of what's happening with the agentic threat. So if I go back through those 10 kind of core categories of threats, let's look at with some of these core security best practices how many of these problems we could protect against. So if we look at identity and authentication or authorization threats, the solution here is really about making sure you correctly configure identity and access management policies from the start. And we can see the different phases, once again, where these occur. For credential and secret management, Vault, we'll talk about HashiCorp. Vault supports centralized secrets management and short-lived credentials. So why wouldn't you use those things to solve a multitude of these security problems? With tool and integration exploits, the use of short-lived creds, once again, helps with that. Also, PKI and certificate management addresses that tool injection problem because you're using TLS or you're using MTLS to make sure that things are being securely connected or communicated by that method. The supply chain attacks, once again, PKI certificates using TLS to protect against those supply chain attacks. The MCP server registry and update or patch mechanisms would be a good example of that. Multi-agent system threats, once again, you need to be able to protect against agent communication poisoning. You can do that with using something like PKI certificates and having TLS or MTLS in place for those agents and sub-agents. In terms of prompt-based attacks, the related data security threats on the next slide, including this one, are going to require a multi-layered approach. So it's probably not surprising. That's often going to require a combination of things like team processes that you put into place. So you talk about the concept of red teaming. This isn't just one simple fix for these types of attacks. Because it's often going to require that combination, and then also some purpose-built AI security tools that we're starting to see evolve. That's because the attack surface of the AI applications is really different from traditional apps. The models are dynamic, behavior changes and all that. So you might want to see some tools or investigate tools that have the ability to do things like inspect and filter inputs to stop some of the malicious attacks, monitoring for output anomalies, hallucinations, track and govern model versions. and then also requiring integration of security at the model lifecycle level. So these are all kind of model changes that come with security thinking about managing these threats and going forward. And what I'm saying is we don't have necessarily the solution for all of these things right now, and they're going to continue to be a problem, but you need to think about these and be investigating tools that help in these ways going forward. Once again, the data security threats, that's another area where you need some of this proactive testing, a combination of security mechanisms, and a layered approach. In terms of runtime and operational threats, once again, short-lived dynamic credentials protects a lot of ground, being able to implement that. Detection and guardrail evasion is an interesting one because it's similar to more AI native risk categories. And addressing these attack vectors is going to require tools that can provide capabilities like automated red teaming, for example, or continuous security testing, so a little bit more sophisticated. For compliance and governance, enable audit logs. Vault has detailed audit logs for any action that takes place within Vault, and having those audit trails makes it possible to meet regulatory requirements and also trace agent actions back to human actors. So, identity brokering is critical to securely managing agentic identity. And we talked about that disconnect between human and non-human identities. And we've all seen the headlines about what happens next when you don't manage that well or you don't connect the two or have the proper policies. So NHIs, I think I mentioned that, outnumber humans 50 to 1. 80% of breaches involve them. 97%, this is really bad, when 97% of NHIs have excessive privileges. Got to solve the privilege problem. Most organizations don't even have a process to offboard API keys when they're out there and they get abandoned and they're sitting around for a long time. So with that, Nick is actually going to talk a little bit about this kind of authentication and authorization.
Yeah, this is really important when you start to think about an agentic system, because an agent is doing something on my behalf. I am not doing the thing. It is the agent which is doing it on my behalf. It's very similar to me just giving my credentials to David and saying, hey, David, can you go and, I don't know, like check my email and tell me what my boss said. Now, I trust David. Many people say I probably shouldn't, but I do. But the thing is, like, David is a trustworthy person. The agent is potentially open to manipulation. We've already seen how there are a multitude of ways that agent can be manipulated. So we have to really, really strongly think about identity in behalf of a sort of a process that an agent is acting on. Now, there is a kind of a common sort of approach called on behalf of, and what that allows you to do is to take a token like a JWT and to add additional information to it which tells you that it is operating on behalf of a particular user. So in this instance, what we're going to take is a service token, an agent token, and we're going to augment that token to say that this agent is acting on behalf of this user, and this user has these privileges. Now, when we kind of go about doing that, it means that we have this approach of basically taking two tokens and creating a third. You can do this with a standard IDP. As I say, on behalf of is a sort of a formal process of OIDC. But that works great for the very sort of edge thing, but like from an internal service perspective, we kind of want to take another approach. And actually, we're going to use Vault to be able to mint those internal identities, because this is happening quite frequently with a number of different agents, number of sub-agents, and we want to be able to refine those permissions every single time to ensure that the agent is doing, well, we don't know that the agent is doing what we want it to do. We're going to assume that it isn't. So what we're going to do is ensure that the agent can only act within a very, very specific bound. And if we don't do that, so let's just say, hey, we're just going to have the user identity. Well, if we just pass the user identity to the agent, then the agent can misuse this. The agent can kind of go wild. It can kind of change its direction. It can either be manipulated or it could just be a bug. But it can then use my privileges to do something that it shouldn't be able to do. And if we look at that another way and we say, well, hey, why don't we just use the kind of the service token, you have exactly the same problem. You know, the sort of without the agent identity, then the customer or the user can potentially trick the agent into doing something and elevating their privileges. So both of those are needed in order to kind of to restrict this. Agent identity is really important, and to create an identity from your agent, you don't just need something which is just like a random ID. You need to be able to have that audit trail and that audit logging, and by that you need to be able to have metadata which represents the agent. So the agent needs a proper token which is similar to what the human user would have, defining its scope. Now with Vault, we can go about that approach by using a Kubernetes token. We can create an identity, and we can swap that for a more rich token, which has got all of that metadata in it. Again, we're putting that into the audit log now, so we're satisfying those things as well. The kind of the practice of that is fairly straightforward, and in terms of the efficiency, we use a plugin into the secrets engine for Vault, which enables us to generate those on behalf of tokens. And that kind of brings us to the sort of the approach of Kubernetes. So how are we going to use this? How do we use Vault inside of Kubernetes? How do we secure those secrets?
That is a great question. So let's dive into this a little bit. Vault has a capability with the Vault Secrets operator to manage secrets in a native way with Kubernetes. So this includes being able to use dynamic secrets, PKI certificates, all the kinds of credentials that you would want to use to keep things more secure. OpenShift OLM supports it for instant upgrades, so that also works as well. Secret transformation is also something that VSO can handle. So you end up with templating that looks familiar with the secrets on the Kubernetes side, and so that's very helpful. So basically, what happens is whoever is managing these things and is familiar with Kubernetes, not familiar with Vault, they don't really need to know anything about Vault or how Vault works because this process is all very native. In terms of identity-based access, authentication in Vault is processed, whether it's human or non-human, by providing identity verification. And you can see there's a wide range of different identity providers that will plug into Vault that you can leverage, so you can use all of those identity providers. And it also is really critical because most organizations are working in a very hybrid environment. You're not just working in often cases, one type of cloud, one type of identification system. There's probably multiple that exist, so you need that to be able to be integrated with whatever you're using to centrally manage security. So multiple auth methods are supported. And then before a client, whether human or machine, can interact with Vault, it has to authenticate. That's really important, and so you need these auth methods. Once that happens, there's a token that's generated, and there is a policy that gets attached to that token. And so whatever entity gets that token, they can only do what they're permitted to do by that policy. And so right here, Vault recognizes NIC's different authentication identities. It can create credentials dynamically based on that identity, and then create access policies based on that as well. When we talk about unified identity in Vault, there's an identity engine that exists in Vault that handles this sort of thing. And when you have a new entity or identity that is authenticating with Vault, it creates that entity. So it is that one, it has a unique ID, it is a unique entity to Vault, but what allows you to use this in a flexible environment is you can have aliases. So there might be different authentication methods that are being used for this same entity, and those are aliases that you have. You can also assign metadata, you can assign policies at that alias level. And so that gives you a lot of flexibility to make sure you have that one entity accessing Vault and wanting to do something, but you're locking things down and enabling things for the various aliases that that entity might have, if that makes sense. And this picture here is kind of what shows that and being able to enable the RBAC for those more complex environments that you find yourselves in with the human and machine identity. Audit logs, that's something that is native to Vault. They're stored in JSON, making them easy to query. Vault automatically hashes any sensitive data, so they're very secure logs with HMAX, SHA-256. There's a unique salt that's used as well, so extremely secure. And this allows you to have that audit trail for things that are going on within Vault because that all gets logged very securely. So let's talk about dynamic credentials a little bit because we saw in multiple examples of the attack vectors, if dynamic credentials had been used, it would have ameliorated that attack. So let's look at the first problem, and that was credentials. So security is all about layered security. If we stop that vulnerability, there would not have been any credentials leaked, sure, but if it wasn't that attack, it would have been another attack. So that's kind of how you have to think. So we should go ahead and assume the credentials will leak, and if they do, you need to ensure that the blast radius is minimized. And the only way you're going to do that is to be able to set just-in-time credentials, ones that have time to live, that can be revoked immediately to solve that problem. Dynamic secrets within Vault are created just in time. There's a unique ID that is associated with each one of those credentials. It's a unique identifier that allows the secret to be audited, located, revoked early if you need to do that. And every application instance or agent gets a different credential with a different time to live. In terms of the support for dynamic credentials, this is a look at the broad range of dynamic credential types that HashiCorp Vault supports. So multiple different types of databases via the database secrets engine, cloud service provider dynamic credentials, LDAP, and then also security or certificates like I mentioned before for PKI and SSH. So there's no reason not to use dynamic credentials when you have all of that available to you. This is an example of the dynamic secrets database engine, and you can kind of see what the flow looks like here. Obviously, the secrets are created just in time, and they ensure that access is automatically revoked at the end of the expiry time for that credential. And with that, I think we're going to look at a quick demo of how this works.
Yeah, so rather than doing like a bit of a deep dive, we can kind of talk about these things. If you want to come over to the booth, I'm conscious of a little bit on time. But ultimately, the way that you can configure all of this, just using Kubernetes as an example, which I think is a fairly sort of common platform these days, is just through using the Vault Secrets operator, which is verified, compatible with OpenShift, and all sorts of things like that. And just by using that configuration through, setting up the database secrets engine, but then injecting those secrets into Kubernetes. We'll kind of skip over this one for the moment. As I said, if you're interested in looking at a technical deep dive, come and find me. I'd be more than happy to run through those schemas and processes in more depth.
On to the next one. Yeah. All right. So let's talk a little bit about certificates. I mentioned that as well, and something especially using TLS or MTLS that's extremely important in protecting against some of these attacks. In this situation, in this attack, if there had been TLS on the system, then the credentials would not have been leaked. Moreover, if there had been TLS on the system, the credentials would not have leaked in this way. And so that's really important too, the way that this happened. So we need to do both things, and it's not hard to implement with the right tooling to make sure you're using dynamic credentials and to make sure that you're using certificates to enable things like TLS and MTLS. Vault supports modern PKI management, and what I mean by that is very automated, very scalable, and Vault is flexible too in the architecture because you can have multiple intermediate certificate authorities that you can configure based on your environment and what your needs are. It can act as the internal root CA, issuing X509 certificates. It automatically enables you to revoke and distribute these certificates in different ways, and I'll show you some of the multiple methods that it can leverage. It also has native support for SPIFFE. So the SPIFFE X509 standard, extremely popular open standard because it allows you to have very granular authorization on certificates and gives you an easy way to manage and scale those identities when you're using certificates. There's also service mesh integration supporting MTLS for service-to-service certificates as well. So let's take a look at what this looks like. There's some examples. So using the Vault agent, this is where the Vault agent is actually connecting to the service or the application. It's keeping track of the time to live on that certificate. So when it knows when it's about to expire, and then it will communicate back with Vault, and it will authenticate, and it will request a new certificate. It gets a certificate, and then it updates that certificate in the service. Vault, meanwhile, is keeping track of all the roles that are accessing it to get certificates, and then being able to use those. It also works in a similar way if we look at the Kubernetes environment, like we were just talking about. The Vault secrets operator is what enables you to integrate with Vault and automate that certificate management and have that work in your containerized environment. So there's different methods. If you look on the left, those are established patterns using the Vault agent and then VSO. They're very opinionated, but on the right, you also see the capability to use less opinionated methods of leveraging this type of capability with Vault. There's the Vault SDK. You can integrate directly into code, and then you can utilize the Vault CLI to authenticate and retrieve one-off certificates. So there's multiple methods when we're talking about flexibility to be able to leverage certificates with Vault. In terms of architecture and scaling, like I mentioned, you can have an offline root CA. You create an intermediate CA. That's kind of your top-of-level wildcard domain. You can have a time to live of a year. You can create another intermediate CA from the top level. It's got a shorter TTL. So you can see how you can architect this and be very flexible with it. And then lastly, you have your instance of intermediate CA that's going to issue those leaf certificates for your application or service and make that 30 days or whatever you need to do. But extremely flexible. In terms of performance, compliance, and scalability, there's disaster recovery that supports warm standbys that can be configured for easy recovery. There's automated deployment. So if this is something that you want to deploy in an automated and scalable way, you can use Terraform to do that. You have audit logging that exists, obviously, that we talked about, so you can generate reports for that purpose. Cross-region support to meet applications where they are from a performance standpoint. And then things like path filters to ensure that secrets are not accessed or stored in Vault clusters where they may be additional compliance. So you think GDPR, and that becomes important too. And if we put it all together, it's just an extremely scalable tier 0 application that you can leverage for PKI. And with that, let's go ahead and take a look at a demo of how this works.
So again, from a sort of a stance on how you go about dealing with this, how do you configure Vault, it's fairly straightforward. If you kind of understand how one of the endpoints work, they're all fairly similar. Conceptually, you have to enable an endpoint. So with PKI, I enable the PKI endpoint, I can generate a root certificate, and then I can configure it. And once I've got all of those kind of things set up, that then enables me to use the Vault secrets operator to use those roles that I've configured. Again, it's linked through to the policy in the service account in Kubernetes. And it will allow me to inject that secret from Vault, dynamically generated, into a Kubernetes secret. So from an application development perspective, there's nothing different here. Now, if we kind of look at all of those things, so if we look at the things that we've talked about, where the vulnerabilities which were core in our demo were that had we had TLS and had we had dynamic credentials, the blast radius would have been far, far, far more reduced. Of course, we're looking at a very, very select problem and in a very select area, but that's the concept of defense in depth. It's not about just doing one thing. You really have to do all the things. With dynamic secrets and with PKI in our agentic application, if we kind of look through and replay that attack, you'll see how things differ. So now we've configured the server to use PKI. Again, the vulnerability still exists. So when I find out what the weather's like, and this time I'm going to kind of ask what the weather is like in Miami, because it's going to be a lot nicer than it is here right now, unless you were in Miami last weekend and you realized that it just rained for 2 days. But conceptually, that same process has gone through, right? The sniffer is now enabled. It's now being sending the credentials back to the attacker. And when we use the same thing using the customer agent, we say, hey, give me the customer order details here. What that is going to do is the agent talks to the tool makes a connection to the database authenticates. You can see that kind of running through in the application. But now when we look at the credentials, we don't see anything. And the reason we don't see anything because the connection between the tool and the connection between the agents and the connection to the database is all encrypted with a standard practice that you've been using for thousands and thousands and thousands of hours and months and years and since the dawn of microservices or any form of sort of secure system. So what are the key differences with agentic systems and microservices? And I think the key thing is that not a lot and actually quite a bit. That's a really sort of ambiguous approach, but the key thing is that an agentic system is very deterministic. You can't necessarily predict what it is going to do. It has this kind of emergent behavior where it'll just act on its behalf. It is more human than it is the kind of that traditional approach where you can just follow the code path through either a single service or a connection of services. The thing that's very much the same is that a lot of the problems that you've fixed in your microservice systems by just employing good sort of secure practices around coding standards, by employing sort of secure systems still applies. There is nothing really, really different. But we do have to be aware. We've got to be planning ahead. We've got to be thinking, what are the threats? Because some of them we just don't know. Like there are things that we know, but the attackers are becoming very, very sophisticated. And because of that emergent behavior, it's opening up new opportunities that just don't exist right now. So if you want to learn some more, then we've got some resources here. You can kind of grab our example repo, and you can kind of, if you want to run Vault on your own or run Vault Radar, you can kind of get a free trial there. And of course, if you want more of a deep dive on the technical side of things, please come and find us in the expo hall, and it would be an absolute pleasure to chat to you about those things. But thank you so much for listening. I hope it's been interesting.
Yep. Thank you all for coming. Hope it was valuable. Enjoy the rest of the event.